Plate tectonics and natural disasters, a deep connection. Plate tectonics and natural disasters, a deep connection. Introduction. The Earth is a dynamic and ever-evolving planet. It is composed of several layers, with the outermost layer, known as the lithosphere, broken into large, rigid pieces called tectonic plates. These ST plates float on a layer of semi-fluid rock called the asthenosphere. The movement of these plates is responsible for some of the most significant natural disasters that our planet experiences. From earthquakes and volcanic eruptions to tsunamis and landslides, plate tectonics plays a crucial role in shaping the landscape and impacting life on Earth. Understanding plate tectonics. Plate tectonics is the scientific theory that describes the movement and interaction of the Earth's tectonic plates. The theory suggests that these plates are continuously in motion, drifting, colliding, and sliding against each other. There are several types of plate boundaries where the plates interact: divergent boundaries, convergent boundaries, and transform boundaries. Divergent boundaries occur when plates move away from each other. This movement allows magma from the mantle to rise and create new crust, forming a process known as seafloor spreading. As a result, underwater mountain chains such as the Mid-Atlantic Ridge and terrestrial features like the East African Rift Valley are formed. Although these boundaries do not directly cause natural disasters, why can trigger volcanic activity and earthquakes as the plates separate. Convergent boundaries form when plates collide. Depending on the type of plates involved, three main types of boundaries can develop: oceanic-oceanic, oceanic-continental, and continental-continental. Oceanic-oceanic plate collisions often result in the formation of volcanic island arcs, such as the Aleutian Islands in Alaska or the Japanese archipelago. These collisions can also lead to underwater earthquakes and tsunamis. When an oceanic plate collides with a continental plate, it can result in the subduction of the oceanic plate beneath the continental plate. This process forms coastal mountain ranges, like the Andes in South America or the Cascades in North America. Earthquakes and volcanic eruptions are common along these boundaries. Lastly, continental-continental plate collision can create immense mountain ranges like the Himalayas. Although these collisions do not directly cause natural disasters, they can lead to significant seismic events and result in the formation of fault lines. Transform boundaries occur when plates slide past each other horizontally. These boundaries are associated with the occurrence of strike-slip faults, such as the San Andreas Fault in California. The sliding motion between plates can cause powerful earthquakes as they become locked and release pent-up energy. The 1906 San Francisco earthquake is a prime example of the devastating effects of plate movement along a transform fault. The impact of plate tectonics on natural disasters. Earthquakes are one of the most prominent natural disasters resulting from plate tectonics. They occur when there is a sudden release of energy in the Earth's crust, typically along fault lines. The movement of tectonic plates causes stress to accumulate along faults until it overcomes the friction holding them in place. When this stress is released, seismic waves are generated, shaking the groove and causing widespread destruction. The magnitude of an earthquake is measured on the Richter scale, which quantifies the energy released by the earthquake. The 2004 Indian Ocean earthquake, with a magnitude of 9.1, resulted in a devastating tsunami that caused widespread loss of life and destruction across multiple countries. Volcanic eruptions are another catastrophic consequence of plate tectonics. When tectonic plates collide or separate, molten rock, magma, from the Earth's mantle can reach the surface, leading to volcanic activity. The movement of plates can create subduction zones, where one plate is forced beneath another, causing the melting of crustal rocks and the production of magma. When this magma reaches the surface, it can result in explosive eruptions or the formation of volcanic vents. The 1815 eruption of Mount Tambora in Indonesia is one of the most significant volcanic eruptions in history. It ejected massive amounts of ash into the atmosphere, leading to a global temperature drop and catastrophic impacts on global weather patterns. Tsunamis, destructive ocean waves, are often triggered by large undersea earthquakes. These earthquakes occur along subduction zones, where one tectonic plate descends beneath another. The sudden displacement of the seafloor during these events can cause a massive displacement of water, generating powerful tsunamis that travel at high speeds across oceans. The 2011 Tohoku earthquake off the coast of Japan, with a magnitude of 9.0, resulted in a devastating tsunami that caused significant damage and loss of life. Landslides are frequently connected to plate tectonics and are commonly triggered by earthquakes or volcanic activity. The shaking caused by seismic events can cause the destabilization of slopes or trigger the collapse of volcanic debris, resulting in landslides. These events can bury communities, block rivers, and disrupt ecosystems. The 1980 eruption of Mount St. Helens in the U.S. state of Washington triggered a massive landslide that swept away vast areas of forest and reshaped the surrounding landscape. Plate tectonics, the movement and interaction of Earth's tectonic plates, is intrinsically connected to natural disasters. The Earth's lithosphere is composed of large, rigid tectonic plates that flow on the asthenosphere, a semi-fluid layer. These plates continuously drift, collide, and slide against each other, leading to significant geological events. There are three main types of plate bone: Daries, divergent, convergent, and transform. Divergent boundaries occur when plates move away from each other. This movement allows magma from the mantle to rise, creating new crust through seafloor spreading. Although these boundaries do not directly cause natural disasters, they can trigger volcanic activity and earthquakes as the plates separate. Notable examples of divergent boundaries include the Mid-Atlantic Ridge and the East Africa and Rift Valley. Convergent boundaries form when plates collide. There are three types: oceanic-oceanic, oceanic-continental, and continental-continental. Oceanic-oceanic collisions result in the formation of volcanoes. Sea island arcs, such as the Aleutian Islands and the Japanese archipelago. These collisions also lead to underwater earthquakes and tsunamis. When an oceanic plate collides with a continental plate, the oceanic plate subducts beneath the continental plate, forming coastal mountain ranges like the Andes and the Cascades. Earthquakes and volcanic eruptions are common along these boundaries. Lastly, continental-continental collisions create immense mountain ranges such as the Himalayas, which can lead to significant seismic events and fault line formation. Transform boundaries occur when plates slide past each other horizontally, forming strike-slip faults. The sliding motion between plates can cause powerful earthquakes, as seen along the San Andreas Fault in California. The 1906 San Francisco earthquake is an example of the devastating effects of plate movement along a transform boundary. Plate tectonics have a profound impact on natural disasters, with earthquakes being one of the most prominent consequences. Earthquakes occur when stress accumulated along fault lines due to plate movement exceeds the friction holding them in place. The release of this stress generates seismic waves, shaking the ground and causing widespread destruction. Volcanic eruptions are another catastrophic consequence of plate tectonics. When plates collide or separate, molten rock from the mantle can reach the surface, leading to volcanic activity. Subductio. End zones, created by plate movement, can cause crustal rocks to melt, producing magma. Eruptions can be explosive or result in the formation of volcanic vents. The 1815 eruption of Mount Tambora in Indonesia is a notable example that influenced global weather patterns due to the massive ash emissions. Tsunamis, destructive ocean waves, are often triggered by large underwater earthquakes along subduction zones. Displacement of the seafloor during these events causes a significant displacement of water, generating powerful tsunamis that traverse oceans at high speeds. The 2011 Tohoku earthquake off the coast of Japan resulted in a devastating tsunami that caused extensive damage and loss of life. Landslides are frequently connected to plate tectonics and are commonly triggered by earthquakes or volcanic activity. Seismic events shake slopes, destabilizing them, or can cause the collapse of volcanic debris, resulting in landslides. These events bury communities, block rivers, and disrupt ecosystems. The 1980 eruption of Mount St. Helens in Washington triggered a massive landslide, altering the landscape significantly. Plate tectonics and natural disasters are incredibly interconnected. By comprehending plate tectonics and its impact on natural disasters, we can enhance our ability to predict and prepare for these.